Okay, we are here with some questions, some numerical questions on rotational dynamics of class 12. Our first question is, a wheel starts from rest and accelerates with constant angular acceleration to an angular velocity of 15 revolutions per second in 10 seconds. Calculate the angular acceleration and angle which the wheel has rotated at the 2 seconds. So here, the first question have some given values. We'll write some given values. And the first thing is that initial velocity, angular velocity of the rotation is 0. Is mentioned at rest, radian per second. त्यसपछि final velocity is given as 15 revolution per second. The final velocity is given in 15 revolution per second. 15 revolution per second. We need to mention it in radian per second, so we will convert it in radian per second. Two pi into 15, that is 94.245 radian per second, and the duration for the change in velocity is 10 seconds. According to the question, we need to find the angular acceleration and the angle made in 2 seconds. Different time for this angle. Different time for this angle is given. So for this calculating angle, we will use different time. Okay, now first calculate the angle. We will use the formula omega 1 is equal to omega naught plus alpha. The final velocity is equal to initial velocity plus angular acceleration into time. 94.245 is equal to 0 plus alpha into 10. Therefore, alpha is equal to 94.245 by 10. That is 9.4245 radian per second square. Now again, to calculate theta, we will use another formula. Theta is equal to omega naught t plus half alpha t square. That is angle is equal to initial velocity into time plus half into alpha into t square. For this, we have to take time 2 seconds. 0 plus 1 by 2 into 9.4245 into 2 square. This comes to be 18.849 radian. Must be clear that the angle measured is in radian, as we have taken the units as radian per second. So this was the solution of our first question. We are here with our second question. A constant torque of 500 Newton meter turns a wheel which has a moment of inertia 20 kg meter square about its center. Find the angular velocity gained in 2 seconds and the kinetic energy gained. So here given items are torque is equal to 500 Newton meter and the moment of inertia is 20 kg meter square. We need to find the angular velocity gained in 2 seconds. So here what we consider, when the torque is applied, the wheel starts to rotate. So its initial angular velocity will be 0. And we need to find the final angular velocity as well as kinetic energy. So The first thing, we need to calculate the angular acceleration using the formula tau is equal to I into alpha. So alpha is equal to tau by I is equal to 500 by 20 25 radian per second square, and then we will use omega 1 is equal to omega naught plus alpha t. This gives 0 plus 25 into 2, that is 50 radian per second. And finally, our kinetic energy will be half I omega square, that is 1 by 2 into 20 into 50 square. This comes to be, I will calculate this value, 25,000 joules. So this is the solution of our second question. Now we are here with our third question. A rotating disc rotates steadily at 45 revolutions per minute on a table. When a small mass of 0.02 kg is dropped gently on the disc at a distance of 0.04 meter from its axis and sticks to the disc, the rate of revolution falls to 36 revolutions per minute. Calculate the moment of inertia of the disc about its center. Okay, so here given is, at the initial condition the disc is rotating at the speed of 2 pi into 45 revolution per minute. This 2 pi is needed because the rotation speed is in revolution per minute. So to convert it in radian per second, the radian per minute, we need to multiply with 2 pi. And finally, when some mass was dropped on the disk, its angular velocity or revolution speed changes to 36 revolution per minute. We again need to write 2 pi into 36 revolution per minute. So what we do, first we consider that the initial moment of inertia of disk be x, that is initial moment of inertia is x. And when some mass is dropped on the disk, obviously its moment of inertia will increases. It will increase by amount mr square. This is equal to x plus 0.02 into 0.04 square. This comes to be x plus 3.2 into 10 power minus 5. Then we will use here the principle of conservation of angular momentum as I1 omega 1 is equal to I2 omega 2. So x into 2 pi into 45 is equal to x plus 3.2 into 10 power minus 5 into 2 pi into 36. 2 pi cancel, and x plus 3.2 into 10 power minus 5 into 36 is equal to 45x. 45x is equal to 36x plus 1.152 into 10 power minus 3, or 9x is equal to 1.152 into 10 power minus 3. So x is given by 1.28 into 10 power minus 4. So therefore, the moment of inertia of the disk is 1.28 into 10 power minus 4 kg meter square. This was the solution of our third question. Okay, now we are here with our fourth question. Speed of a body spinning about an axis increases from rest to 100 revolution per minute in 5 seconds. If a constant torque of 20 Newton meter is applied, the external torque is then removed uh, and the body comes to rest in 10 seconds due to friction. Calculate the frictional torque. So here in this question, the question is divided into two parts. The first part is accelerating part where some torque is applied, and because of this torque, the uh, speed of the body spinning increases from 0 to 2 pi into 100 revolution per minute in 5 seconds. So omega 1 will be equal to 10.47 radian per second. The second part is that when that external torque was removed, the body starts to come to rest. So for that, our initial speed will be 10.47 radian per second, and the final speed will be rest, because it is retarding, be rest, and this takes times 100 second. Obviously this is the retardation, so there is friction, and we need to find that frictional torque, what frictional torque is applied because of which the speed is retarding. So first we'll solve the first part. From the first part, we need to calculate first accelerating acceleration. So omega 1 is equal to omega naught plus alpha t. 10.47 is equal to 0 plus alpha into 5. So alpha is 2.09 radian per second square. Again, we need to also calculate the moment of inertia of the spinning spinning body. So for that, we need torque is equal to I alpha. So 20 is equal to I into 2.09. So I will be given as 9.54 kg meter square. This moment of inertia can be used in the second part. Again, for the second part, we need to calculate the retarding acceleration. So omega 1 is equal to omega naught plus alpha t. This is 0 is equal to 10.47 plus alpha into 100. Alpha is given by 0.1047 radian per second square in minus sign because it is retardation. Need to write here retardation portion. So if the retardation acceleration is 0.1047, then what will be the retardation force or frictional force? Will be equal to I into alpha. I is calculated as 9.54 into 0.1047. This comes to be about 1 Newton meter. This is the answer of our fourth question. Okay, we are here with our last question, fifth question of the rotational dynamics of class 12. A particle starts from rest according to the formula theta is equal to t square by 20 minus t square by 3. Calculate the angular velocity and angular acceleration at the end of 5 seconds. So this is a mathematical question. Here the angular displacement is given by theta is equal to 3t square by 20 minus t square by 3, and we need to calculate the angular velocity. So we know that angular velocity is defined as omega is equal to d theta by dt. So d by dt 3t square by 20 minus t square by 3. This comes to be 6t by 20 minus 2t by 3. So at t is equal to 5 seconds, what will be the value of omega? 6 into 5 by 20 minus 2 into 5 by 3. 6 5 are 30, 30 by 20, 1.5 minus 2 5 are 10, 10 by 3, 3.33. So this comes to be negative value minus 1.833 radian per second. Again, we need to calculate angular acceleration. So angular acceleration is defined as alpha is equal to d omega by dt. So this comes to be d by dt 6t by 20 minus 2t by 3. This is 6 by 20 minus 2 by 3. Is equal to minus 11 by 30. This is minus 0.366 radian per second square. This is the constant value because the value of alpha is independent of time. So angular acceleration is constant here. This was the answer of the fifth question, last question of rotational dynamics. Thank you, everyone.